So here's the meaty part of tonight. If we want to add or subtract fractions, there's different ways to do it. We're going to do lots of examples, and we'll see that sometimes certain ways are nicer and other ways are not. You are allowed to have a favorite way. If you like one way more than others, you can just sort of always do that way. So the first method we'll talk about is the brute force method. So in the two examples we've done before, we've multiplied each denominator, each bottom number, by the other one. So the 3 and the 4 we multiplied together. Or in the previous example, the 3 and the 2 we multiplied by together. That will always work. If we want some number on the bottom to be the same, if we multiply the two different numbers together, it will turn into the same thing, right? It will both be this number times that number. The order doesn't matter when we multiply. So I will do that. I have 136 plus 16. Then I will multiply this one by 6 and this one by 36. If I do something to the bottom, I have to do it to the top. If I cut this into 6, each of these 36 into 6 pieces, then each of them now is 6 pieces, right? And I count them at the top. So I need a times 6 up here and a times 36 up here. I wind up now with 6. And what is that 36 times 6? Let's get my thing. 36 times 6 is 216. Plus 36, 216. When I add fractions, I'm just adding the tops. That's the counting how many we care about number. The bottom is just the piece size. So 6 and 36 would make 42. And I would be done, except for that annoying rule that fraction math doesn't count as done until you reduce things. And here is the drawback of the brute force method. When I multiply each number by the other, then I get something that's the same automatically. It's just 36 times 6. But it's pretty big. There's probably going to be a bunch of reducing that I have to do at the end. So I start out very quick, like those little Volkswagen Bugs at the red lights that take off with their tiny little engines that have such gear ratios. But then my top speed is really slow because now I have to really do a lot of reducing. Okay, what can I divide top and bottom by?
8.
5 times 8 is 40, so 8's not gonna work. 6. 6. What's 42 divided by 6?
7.
7. And 216 divided by 6, we know it's just here. We got it with a times 6 from 36. So if we divide by 36, then we're back there. Okay. If you divided by 2 and then divided by 3, that would work also. If you didn't notice that 6 would work as one step. So that's the brute force method. Multiply each denominator by the other and deal with the consequences. Questions about that before we move on to the next one?
What did you do to get 36 over 216?
I saw that this one was 1 times 36 is 36.
Okay. Oh, okay.
And then 6 times 36, I used my calculator. The list of multiples method says that was icky. I don't like having 216 on the page. That's too big. I had to do all this reducing. So I'm going to do more work in the beginning. I can't just escape work, but I can do more in the beginning and then less at the end. So I'm going to write out my multiples. So of 36, my first denominator, I have 36, 36 times 2, 72. Maybe that's as much as I need. Then with 6, my other denominator, 6, 12. I'm looking for something on both lists. I have to keep going, right? 18, 24, 30. I found something on both lists. So I stop. Now here's something cool. This was times 1 for the 36 list. This was times 1, times 2, times 3, times 4, times 5, times 6 on the 6th list. Right? 6 times 6 was 36. I can count on my list of multiples to see what I needed to multiply by to get my starting number to my number that I said, yes, that's the one I want. That means when I am writing my addition problem, let's start over. Notice, by the way, that I leave space between the first fraction and the plus. I know I'm going to be writing little floating multiplies there, so I want to physically leave space on the paper. So the 36 was just times 1. I don't even have to write that. If you wanted to, I could put times 1 top and bottom, but times 1 doesn't do anything. The 6th one was a times 6. And how do I know it? Because it was times 1, times 2, times 3, times 4, times 5, times 6. You can have your multiple list go farther than you know your times tables by heart and just count the multiple list to see what that number is. Now, when I keep going, what number was on both lists? That's my denominator on the bottom. And then 1 times 6 is 6. Then 1/6 plus 1/36 plus 6/36, 1 plus 6 is 7. I get the same answer, of course, but I don't have to do all that reducing. This is a very popular method that people like. Reducing scares people more than making lists of multiples. The more people like making multiples. So the trick is you don't want to go too far, like we did in 72, and do some extra work. There are some calculators that can make these lists if you just repeat the equal sign. You can go 6 plus 6 equals, and it will just build your list of multiples of 6 for you. But even if you don't have a calculator that does that, just adding a number repeatedly usually is pretty fast on the calculator. 6 plus 6 plus 6 plus 6 plus 6. Yeah, you can build your lists. Hopefully you have multiplication tables memorized well enough that for the numbers you'll see most of the time, you can make your list very quickly without a calculator at all. Okay, ready for the last method? Yes, okay, the prime factorization method needs a little more space. So I'm going to make more space. Okay. So I will get rid of, actually, I will clear the frame and just copy into that. I can do it compactly, but I don't want to the first time you see this. So we are still adding 1/36 plus 1/6, same problem. What was the kind of shape, the game we played with prime factors? What was that?
I don't know what it's called.
What do we call it? We split them and
And then I know that we're done. I don't really know what that game is called.
factor trees.
Oh.
They were making factor trees. It wasn't actually a game. But
Oh.
so we're gonna make a factor tree of each denominator. We need a factor tree for 36. And we need a factor tree for 6. Ready?
Yeah.
Okay, so 36. What do we do with 36 as a factor tree? 6 times 6. Okay, if you didn't do that, if you did like 3 times 12, that's fine. Remember, there's more than one ways to make a factor tree. They all end up the same. We've done that the other day. So 6 is 2 times 3. And then my factor tree for the other denominator, there we go. Everyone okay with my 2 factor trees?
Yeah.
Okay, here is the magic process. Step 1. Any number that's a leaf on both trees, write it once. So there's a 2, and I cross it out on both trees at the same time. Then there's a 3, and I cross it out on both trees at the same time. I do that as much as I can. Any number that's a leaf on both trees, I write it once, but I cross it off on both trees. Then my next process is the leaves that were only on one tree, but not the other tree. I have to write those also. So there's another 2 and another 3, and I'm using dots for multiplying. Hopefully that's okay. So what is 2 times 3 times 2 times 3? So 2 times 3 is 6, times 2 times 3 again, 6 times 6, we're back up to 36. This is another way to see that 36 is my common denominator. So I'm going to have something that's 36 as my common denominator. Well, this one is obviously 136 because that's what it was before. In the list of multiples, I had that cute thing where I could count my multiples and get to 6 and know that that was a times 6. What is my cute thing here? It turns out it's the ones that were only on one tree, and that's why I wrote them. Right? That's what goes over here, the times 2 and times 3. You could write a times 6 if you want. So 1 times 2 is 2, times 3 is 6. So this becomes a 6 there. And just like before, when we add them up, 1 plus 6 across the top is 7 pieces of pancake. How big are they? They are 36. Compared to the list of multiples, this takes up a lot more board space. But if you practice it a lot, this is the fastest method. So if you unfortunately have a job where you have to add fractions a lot by hand without a calculator, it's worth learning this one and getting good at it. It's like riding a bike. It will make you happy and serve you in your life. If you don't have to add fractions very much, most people pick the list of multiples method because it's about the same speed if you don't have a lot of practice, and it's sort of simpler and doesn't take up as much room on the paper. They are all 3 good methods. It's not like anyone gets the wrong answer. It's just whether you want to do a lot of work at the end or whether you want to do this kind of work at the beginning or whether you want to do this kind of work at the beginning. So I'm going to stop this video and then start a new video for the next example problem.